In 1985, a physicist in Montana built a home that has not needed a furnace in nearly 40 years. No solar panels, no heat pump, and no monthly energy bill. He buried a simple insulation umbrella underground, and the earth itself became his heater. It stored summer warmth and released it all winter long. But the heating industry buried it even deeper. By the end of this video, you will discover exactly how it works. His name was John Haight, not a contractor, not an architect, a physicist. He lived in Missoula, Montana, where winter temperatures regularly plunged to minus 30 degrees Celsius. While the rest of the construction world kept building the same insulated boxes and filling them with furnaces, Haight asked a question nobody in the heating industry wanted to hear. Why are we burning fuel to heat air inside a structure when the largest thermal battery on the planet is sitting right beneath our feet? Every conventional home you have ever lived in was built the same way. Insulate the walls, insulate the roof, seal the building from the ground, then spend a fortune heating the air trapped inside. Haight looked at this model and saw it backwards. The earth was not the enemy to be sealed out. The surface was the enemy letting stored heat escape. So he proposed the exact inverse of everything the industry taught. Do not insulate your home from the earth. Insulate the earth from the sky. Let the ground do the work. In 1983, Haight published his findings in a book called Passive Annual Heat Storage. The physics have never been debunked. The book is still in print today. His Montana home is still standing and still heated by nothing but dirt. Yet almost nobody has heard of him. That silence is not an accident. It is not an oversight. And once you understand why, you will never look at your furnace the same way again. But Haight did not invent this from nothing. The principle he quantified is thousands of years old. Entire civilizations were built on it. And then somehow the modern world forgot. Travel to Cappadocia in central Turkey. Beneath the dusty surface lies Derinkuyu, an underground city carved from volcanic tuff beginning around the 8th century before the Common Era. This was not a small shelter. Derinkuyu descends more than 60 meters into the earth. It housed up to 20,000 people, livestock pens, storage rooms, chapels, ventilation shafts, all carved from stone deep below the surface. The interior temperature held steady between 13 and 15 degrees Celsius year-round, while the ground above baked at 40 degrees Celsius in summer and froze in winter. The people underground lived in stable, comfortable conditions. They had no thermodynamics textbooks. They had something better: generations of observation. The earth at depth holds its temperature. They knew. Now travel east to ancient Persia around 400 years before the Common Era. Engineers there built massive domed structures called yakhchals with deep underground vaults. These were ice factories in the desert. In a climate where summer temperatures exceeded 40 degrees Celsius, Persian builders manufactured and stored ice using nothing but the thermal mass of the earth and the cold of winter nights. They charged the ground with cold during winter and harvested it through summer. This was annualized thermal storage operating in reverse, executed flawlessly more than 2,000 years before anyone gave it a scientific name. Then look to Rome. The hypocaust system of the 1st century before the Common Era channeled heated air beneath raised stone floors. Roman engineers understood that heating the mass of stone and earth beneath a building produced sustained, even warmth far superior to heating the air above it. They were deliberately charging thermal mass. 3 civilizations, 3 continents, 3 millennia, all converging independently on the same principle. The earth stores energy across seasons. This is not theoretical. It is among the most battle-tested construction principles in human history. So if ancient builders understood this instinctively, what exactly did John Haight add? He added precision. He turned an ancient instinct into a reproducible engineering system. And what he designed is almost dangerously simple. Here is the problem Haight identified with the earth-sheltered homes of the 1970s. Dozens of architects and builders had experimented with burying homes underground during the energy crisis. Most of them insulated the building shell from the surrounding soil, treating the ground as something to be sealed away. This was the critical error. By insulating the house from the Earth, they cut it off from the very thing that could have heated it for free. The Earth was trying to help. The builders were blocking it. Haight flipped the model entirely. His invention is called the Passive Annual Heat Storage Umbrella. Picture a continuous horizontal sheet of rigid extruded polystyrene insulation, 5 to 10 centimeters thick. This sheet is buried 30 to 45 centimeters below the ground surface. But here is the key. It does not wrap the house. It extends outward from the building foundation 6 to 8 meters in every direction, like a massive underground parasol. The umbrella does not insulate the home from the Earth. It insulates the Earth from the atmosphere. That single inversion is the entire breakthrough. Think about what happens physically beneath that umbrella. It creates a thermally isolated Earth mass around and under the home. We are talking about 300 to 500 tons of soil, completely cut off from the temperature swings at the surface. During summer, solar radiation and warm air heat the ground above the umbrella. That warmth conducts slowly downward and inward through the soil toward the building foundation. The journey takes weeks, sometimes months, and when winter arrives, the umbrella prevents that stored heat from radiating back up into the freezing sky. By January, the warmth deposited in June has migrated to the foundation zone. The home sits inside a warm cocoon of earth, releasing stored energy through the slab and walls by simple conduction. The results from Haight's Montana prototype are staggering. Interior temperatures stabilize between 18 and 22 degrees Celsius year-round. No furnace, no boiler, no heat pump running outside. Montana winter dropped to -30. Inside, the home held steady at a comfortable 20 degrees. The annual heating cost was zero. Haight added another elegant layer to the system. Buried air intake tubes made from PVC or corrugated high-density polyethylene, 15 to 30 centimeters in diameter, run 15 to 30 meters underground at a depth of 2 to 3 meters. These earth tubes precondition fresh ventilation air before it enters the home. In winter, outside air entering the tubes at -20 degrees warms to roughly 8 to 12 degrees Celsius just from contact with the stable soil around the pipe. In summer, hot air is cooled by the same mechanism. Research documented by the American Society of Heating, Refrigerating, and Air Conditioning Engineers confirms that earth tube systems consistently shift incoming air temperature by 10 to 15 degrees toward the stable soil baseline. No moving parts, no electricity consumed, no maintenance schedule, no replacement cycle. The fuel is sunlight hitting dirt. The mechanism is heat moving through soil. The operational lifespan is essentially geological. The physics are proven, the data is documented, and Haight was not the only one who proved it works. Homes built on this system have been quietly operating for decades. The evidence is not thin. It has been deliberately overlooked. John Haight's home in Missoula has been running for nearly 4 decades without mechanical heating. Documented interior temperatures hold stable through Montana winters. This is not a simulation or a projection. It is a continuously occupied proof of concept, quietly proving itself year after year while the rest of the country writes checks to utility companies. Other owner-builders followed. Through the late 80s and 90s, they worked directly from Haight's published methodology, scattering passive annual heat storage homes across states and provinces. The reports that came back were remarkably consistent, dramatically reduced heating bills or no heating bills at all in climates that would crush a conventional home the moment the furnace failed. The science holds up from multiple directions. Oak Ridge National Laboratory published data showing that soil temperature at 3 to 4 meters deep stays nearly constant year-round, hovering close to the local mean annual air temperature. Researchers at Nottingham and Loughborough universities produced peer-reviewed studies on annualized geostorage, confirming that residential soil masses can feasibly store seasonal thermal energy. No credible institution has contested the underlying physics. They simply do not promote them. The ground source heat pump industry is a multi-billion-dollar global market. These systems extract stored warmth from the earth using compressors, refrigerant loops, and electricity. They require maintenance, replacement parts, monthly power bills. Passive annual heat storage does the same thing for free with no mechanical components. The heat pump industry has validated the science while quietly monetizing the middleman. So why is this not in every building code? Why is it not taught in every architecture program? Why have you never heard of it? The answer is worth more than the technology itself. Start in 1985. Saudi Arabia opened the taps and flooded global oil markets. Crude collapsed from over $30 a barrel to around $10 a barrel. Overnight, the economic pressure to find alternative heating methods evaporated. Politicians who had championed energy independence moved on. Federal research dollars followed the price of oil straight down. The Reagan administration gutted the Department of Energy's budget for renewable and efficiency research, and approximately 85% CUT between 1980 and 1989, according to Congressional Research Service records. Earth-sheltered housing studies were already a small line item. They were among the first eliminated. The message from Washington was clear: cheap oil is back, stop looking for alternatives. The industry that profits from your dependence reinforced the silence. The U.S. residential heating and cooling market generates roughly $120 billion every year in furnaces, boilers, heat pumps, ductwork, refrigerant filters, installation labor, and service contracts. A technology that eliminates the need for all of it is not an innovation to this industry, it is an existential threat. Not one major HVAC manufacturer has ever funded, tested, or promoted passive annual heat storage research. That silence is not accidental. Building codes lock the door further. The International Residential Code and the International Building Code contain zero provisions for annualized earth thermal storage. None. If you want to build a PAHS home today, you need engineering variances, custom approvals, and inspectors willing to evaluate blueprints they have never seen. When the code does not recognize a construction method, lenders will not finance it. Insurers will not cover it. The system does not need to ban PAHS, it just pretends it does not exist. Fannie Mae and Freddie Mac have historically penalized non-standard construction in their underwriting guidelines. An earth-sheltered home with a PAHS umbrella faces higher borrowing costs or outright loan denial, not because the engineering is flawed, but because the financing system was never built to recognize it. Families staring at mortgage rejection letters for a home that would never need a heating bill, that is the system, working exactly as designed. There is no single villain here, no secret memo ordering suppression, just a web of aligned financial incentives where every gatekeeper benefits from the status quo. Energy companies sell fuel, manufacturers sell equipment, code bodies maintain standards written around that equipment, mortgage agencies lend against conventional construction. Every link in the chain profits when you keep paying to heat air inside an insulated box. The suppression of PAHS is not a conspiracy, it is an economy. But information cannot stay buried forever. Online communities of owner-builders, permaculture designers, and off-grid engineers are sharing Haight's methodology openly across forums and platforms worldwide. His book has found a new generation of readers who are not waiting for permission, they are building energy independence with their own hands. Modern building science is converging from another direction. The Passive House Standard, developed at the Passive House Institute in Darmstadt, validates everything Haight proved decades ago. Preventing heat loss is vastly more efficient than generating heat. Passive House focuses on super insulation and air tightness above ground. PAHS manages thermal mass below. They are not competing approaches. They are complementary halves of the same solution. A home with a PAHS umbrella beneath and Passive House level air tightness above may represent the most energy-efficient residential construction method on Earth. The umbrella itself is among the cheapest components in any home build. It is simply sheets of rigid foam insulation and the labor to bury them. The barrier was never cost, it was always knowledge. For nearly 40 years, a physicist's elegant solution sat in plain sight while the world kept paying to heat air trapped inside insulated boxes. The earth was always the answer. Hundreds of tons of soil beneath every home, absorbing warmth from the sun, holding it across seasons, and releasing it when needed. Free, silent, permanent. The technology was never lost. It was buried right beneath the surface, waiting. You start with the site. Well-draining soil is essential. A water table at least 4 to 5 meters below your intended foundation is required because saturated soil conducts heat too fast and undermines the whole storage effect. Get a geotechnical survey before you break ground. You need to know what you are working with. Then you dig. Excavate the entire building footprint plus an additional 6 to 8 meters in every direction, creating a broad, shallow basin for both foundation and insulation umbrella. Go down approximately 1 to 1.5 meters below your planned finished floor, accounting for drainage gravel, insulation, and backfill. Grade the exposed soil to slope gently away from center. Any groundwater that reaches this level needs to drain toward perimeter collection trenches. Lay a 15 to 20 centimeters bed of washed gravel across everything for drainage and a stable base for what comes next. The insulation goes on top of the gravel. Use continuous sheets of rigid extruded polystyrene 5 to 10 centimeters thick with joints overlapped by at least 15 centimeters and seams sealed with foam, safe adhesive, or tape. No thermal bridging. This layer extends horizontally from your future foundation walls outward for 6 to 8 meters in all directions. That is the umbrella, isolating the thermal mass beneath your home from atmospheric temperature swings above. Before the foundation pour, install the earth tubes. Use PVC or corrugated high-density polyethylene 15 to 30 centimeters in diameter, running through trenches 2 to 3 meters below finished grade. The runs should stretch 15 to 30 meters from an intake point well away from the building to entry points through your foundation walls. Slope them at a minimum 2% grade toward a condensation drainage point, because warm, humid air entering cool tubes will shed moisture that has to go somewhere. Cap the outdoor intake with a screened, rain-protected housing positioned to draw clean air. Now the inversion that makes everything work. Pour your foundation directly on the soil mass above the insulation umbrella, deliberately omitting the underfloor insulation that conventional construction requires. You want maximum thermal contact between your floor slab and the earth beneath it. Stored heat needs to conduct freely into your living space. Use reinforced concrete, at least 10 to 15 centimeters thick, on a thin sand leveling layer above gravel and soil. Slab edges tie into foundation walls that are also in direct contact with surrounding earth. Perimeter walls extend to the frost line or deeper, but do not insulate interior faces below grade. You are maintaining the thermal bridge between home and warm soil mass. Backfill carefully once the foundation is complete. Use original soil or clean fill, compacted in 15 to 20 centimeters lifts to prevent settling. Do not damage the umbrella. Verify that it remains continuous and sealed. Final grade slopes away from the foundation for surface drainage while maintaining 30 to 45 centimeters of soil cover over the insulation for protection from ultraviolet light, roots, and surface activity. Build above grade with high-performance envelope techniques. The PAHS system eliminates most heating loads, but minimizing heat loss through walls and roof still matters. Use triple glazed windows, continuous exterior insulation, and meticulous air sealing at every penetration and joint. Passive house principles complement below-grade thermal mass perfectly. Connect earth tube terminations to ventilation distribution. That can be as simple as a low-wattage fan drawing pre-conditioned air through the tubes, or a fully passive stack effect system if your design allows sufficient height differential. A new PAHS home needs 1 to 3 full seasonal cycles before the soil mass reaches stable operating temperature. You may need supplemental heat the first winter or two. Monitor performance with thermometers or data loggers at floor level and at various heights. Watch the thermal wave from summer migrate through the soil and begin moderating your interior. After charging, the system sustains itself, with summer solar gain replenishing what winter draws. It is a permanent annual cycle requiring no fuel, no maintenance, and no mechanical intervention. The knowledge exists, now you have it too.